Section 10.4, we're going to use inscribed angles and polygons. We're going to find the measures of inscribed angles and learn what they are, and then use angle theorems and postulates to find missing information. So, an inscribed angle is different from a central angle. An inscribed angle is an angle whose vertex lies on the circle and whose sides are chords of the circle. So you have this vertex of the angle is on the circle itself, and the sides right here are chords. And that is called an inscribed angle. So the intercepted arc is the arc that is between those chords. So in this picture, angle TOM is the inscribed angle, and arc TM is the intercepted arc. Remember, sometimes it's going to be easier to see this intercepted arc if you extend those chords a little bit. So here's an interesting piece for your notebook. If you draw a circle with center P and draw an inscribed angle, and then draw a central angle with the same intercepted arc, you can find that there's a relationship between the inscribed angle and the central angle. So if we look at this diagram right here, here is our inscribed angle, 63 degrees. Notice this is the arc that it's intercepting. And if we look at our central angle right here, you can see that it's intercepting the same arc. But it's also pretty clear that the angle measures are not the same. One is acute and one is obtuse. So the relationship is that it happens to be, we already know that the central angle right here and its intercepted arc are the same. And so what happens is, if it's an inscribed angle intercepting the same arc, it's going to be half the measure. So that's your inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. Remember, an intercepted arc is measured in degrees from its central angle. So here is the intercepted arc for this central angle, and those will have the same degree measure, so that will be 126 degrees, just like the intercepted arc. And the inscribed angle that intercepts that same arc is going to be half the measure. Or you can say that the intercepted arc is twice the measure. And again, this is kind of important, is that inscribed angles and central angles have to sort of eat the same arc to use the theorem. In other words, they have to intercept the same arc right here in order to use this theorem. And it's kind of like the Pac-Man is kind of where we're saying eat the arc. So let's practice some problems. It says find the measure of arc BC. So I want to find this arc right here. Well, I can see that this is an inscribed angle that is intercepting that BC arc. So that means that that arc is going to be twice 76, or 76 times 2, so 152 degrees. Okay, now we want to find the measure of angle A. We want to find this right here, that angle measure. Well, we can see that that angle is an inscribed angle because it's on the circle itself. And so arc CB is twice as big as that angle, or the angle is half as big, so that will be 16 degrees. Okay, let's try a few more. So now it says find the indicated measure. We want to find the measure of arc AB. So we want to find the measure of this arc right here. Well, what do we know? We know that this is a 20-degree angle right here. And we also can see that this right here is a diameter. We can tell that because the endpoints are on the circle and it's going through the center. So if that's a diameter, we know that it's also intercepting this arc right here. So that BAC is going to be twice as much as that inscribed angle of 20 degrees. So if this is a diameter right here, then the rest of this arc is going to have to be 140 degrees, because with arc addition, you're going to have both of those adding up to 180 degrees. So now what that does is it makes this central angle right there also 140 degrees. But we found the intercepted arc already. So the measure of arc AB is 140 degrees. In the next question, they are asking us to find the measure of JLM. So again, let's mark. We want to find this angle measure right there. Well, let's see what we know here. We know this is 88, so we have a vertical angle is also 88 degrees. And we also know, and sometimes this might not be as clear to you, but this right here, LP and PM, are radii. They go from the center and have endpoints on the circle, so those are the same. So that means this angle will also be the same. And so if I take 180 and subtract the 88, that gives me 92 degrees left over for the triangle, but there are two angles that are congruent, so that gives me 46 degrees for both of those angles. So the measure of angle JLM is 46 degrees. So the arc-intercept postulate says if two inscribed angles intercept the same arc, then the angles have to be congruent. So if you look at this angle right here, it's intercepting this arc. And of course we know that that arc would be 100 degrees, twice as big. But we also know that this inscribed angle is intercepting that same arc. So that means those two angles, even if they weren't marked congruent, would be congruent. So let's try a few more examples. Find angle K. So we want to find this angle K right here. Well, this angle K is intercepting this arc. Angle L is intercepting the same arc. So if we know that angle L is 28 degrees, then angle K will also be 28 degrees. Now let's find the measure of angle B right here. So again, there is what you're trying to find. So we know that this angle right in here is intercepting this arc. But we also know that this angle right here, inscribed angle, is intercepting that same arc. So if we could find the measure of angle C, then we can find the measure of angle B. Well, again, these are radii. I don't even have to do the triangle sum theorem. I know that this is going to be 32 degrees, so the measure of angle B is also going to be 32 degrees. So now, let's talk about inscribed polygons. An inscribed polygon is when all of the vertices lie on a circle. And a circumscribed circle is a circle that contains all of the vertices of the inscribed polygon. Well, it turns out with quadrilaterals that a quadrilateral can only be inscribed in a circle if its opposite angles are supplementary. So the only way any quadrilateral can be inscribed in a circle where each vertex hits the circle is if the opposite angles are supplementary. So what that would mean is that angle O plus angle H would have to be equal to 180 degrees. So those are the opposite angles. So angle T and angle M are opposite angles. So that would also be true for those two angles. So they have to be supplementary. That's what theorem 10.10 says. So let's try a couple more examples. So it says find the value of x and y. Well, because this quadrilateral is inscribed in a circle, that means that these two angles have to be supplementary. So that means that 3x plus 63 has to equal 180 degrees, or 3x has to equal 117, so x equals 39. And likewise, these two angles are opposite and would be supplementary. So we'd have 4y minus 1 plus 65 equals 180, or 4y plus 64 equals 180. And when we solve, we're going to get y equals 29. So you can make sure you can solve that correctly, but I know that your algebra skills are pretty good. All right, we have one last example here. Find the value of x and y. So again, we know that the opposite angles are going to be supplementary. But if I try to set up this, I'm missing some pieces. So what do I know? Well, I know that this angle right here, angle B, that is an inscribed angle. So I know that this angle measure right here is going to be half of its intercepted arc. Well, I know the intercepted arc is 80 plus 84, which is 164. So that makes this angle half of 164, which is 82. So this is 82 degrees. So now I can set up the equation, since these angles right here, angle D and angle B, are opposite angles, and in an inscribed angle they have to be supplementary. So 7y plus 82 would have to equal 180. So when I subtract 82, I get 98, and then I divide by 7, and that gives me 14. Okay, now I'm going to do the same thing. I can do the same thing for finding angle A. And if we get a different color here, angle A right here is the sum of the 80 and the 152. So angle A is going to be, if I take 152 and add it with 80, that gives me 232. But I have to divide by 2. And so that gives me angle A right there is 116. So this is 116. And so that means that angle A of 116 plus 4x has to equal 180. And that gives me 64. And x equals 16. So that's our work with inscribed angles and their intercepted arcs.